Today, we're jumping into the pretty intense world of modern refineries, and we're going to look at a new playbook that's designed to completely change how they operate. And we're not talking about just a few small tweaks here. This is about giving these enormous industrial complexes a whole new way of thinking.
So let's just start with a big question, a kind of what-if scenario. What if a refinery could actually think for itself? I don't just mean running on autopilot. I mean continuously making the absolute best decision across its entire operation, every single second of every day.
Because here's the thing. The biggest problem in refining isn't about preventing one single catastrophic mistake. It's about this constant, slow bleed of value. It's a classic death by a thousand cuts, where thousands of small, disconnected, and just slightly off decisions add up, day after day after day. So, to really appreciate the solution, we've got to get our heads around the problem first. Let's take a look at where all these thousand cuts actually come from. You know, even in these incredibly advanced facilities, the way decisions get made is often surprisingly fragmented. Planning happens in these big, scheduled batches. Individual units are busy optimizing for their own little world, often without seeing the bigger economic picture. And believe it or not, a ton of coordination still happens with spreadsheets and people manually checking in with each other. The whole system is basically always reacting instead of getting ahead of things.
And this right here shows you what that actually costs. Margin just leaks away. Energy gets wasted. And to play it safe, operators build in these huge conservative buffers that, well, they kill efficiency. The refinery gets slow to react when the market shifts, and it becomes really fragile when something unexpected happens, like a shipment gets delayed or a piece of equipment goes down.
Okay, so this is where a totally new approach comes into play. One that's designed to finally connect all those separate pieces and stop that slow bleed of value. They're called Autonomous Optimization Models, or AOMs for short. Now this is really important. These AOMs don't replace the control systems already in place. Instead, think of them as a new intelligence layer that sits right on top, creating this closed loop that's constantly learning and optimizing everything from the initial forecast all the way to the final execution. This is a massive shift in thinking. We're moving away from just using isolated optimization tools that a person has to decide to run every now and then. We're moving to an always-on optimization system that builds that intelligence right into the fabric of the refinery's operations. So, how does this all actually work? Well, the architecture is surprisingly simple and really smart. It's built on a two-layer approach that's all about getting results fast while also allowing for deep specialization. First, you lay the foundation with what are called ready-made AOMs. These are basically pre-built models that solve the kind of common problems you'd find in any complex supply chain. They deliver value, and they deliver it fast. Then, on top of that solid foundation, you build tailored AOMs that go after the unique, high-value problems that are specific to that one particular refinery. So this foundational layer is really built on four core engines. First up, you've got the agentic forecaster. Just think of it as a smart agent that's always predicting demand. Next, the allocation maximizer jumps in when supply is tight to figure out who gets what to make the most money. Then, the smart replenishment orchestrator manages all the inventory flows. And the dynamic lead time injector, it replaces old guesses with real, data-driven predictions for things like shipping times. You put them all together, and they form this stable, coordinated nervous system for the entire operation. So once that nervous system is in place and running smoothly, you can start teaching it specialized skills. The tailored AOMs, they focus on the really complex puzzles that are unique to that refinery. Things like optimizing the perfect crude blend for maximum yield, or fine-tuning energy use across the entire plant. This is really where a refinery carves out its unique competitive edge. Okay, so how does a refinery actually make this happen? I mean, it's not a flip-a-switch kind of deal. It's a really logical, phased journey that's designed to build momentum and, get this, actually fund itself along the way. It kicks off with Wave 0, which is all about getting that foundational layer in place for some quick wins. Then Wave 1 immediately uses that new foundation to go after commercial value. Think better trading, smarter logistics. Now the profits you make from that wave help pay for Wave 2, which turns the focus inward to core operations. And then finally, Wave 3 embeds safety and reliability, making the whole system not just efficient, but resilient and sustainable. So the end result of this whole journey is a fundamental shift in how the refinery operates, right down to its core. It's about moving beyond just constantly trying to manage complexity to actually mastering it.
You shift from running your optimization models maybe once a week or once a day to a state of continuous, real-time optimization. It's always on.
You move from having different teams making decisions in their own little bubbles to a single unified system where every decision is coordinated and understands its financial impact on the entire business.
And this is so crucial. You go from planning based on static, old assumptions to a system that is constantly learning from what's happening on the ground and adapting in real time.
The source material really puts it perfectly. This isn't just about becoming more efficient. It is about achieving a state of complete mastery over an incredibly complex system, allowing it to perform at its absolute peak all the time.
And this way of thinking isn't just for refineries. It's really a blueprint for any complex industrial system out there. Which leaves us with a pretty fascinating final thought. What's the next complex system? A city's power grid? A global shipping network? Maybe even a hospital that's going to learn to think for itself?